Most people think dreams are just noise, random clips your sleeping brain throws together because it's bored. That's the comfortable answer, and it's wrong. Because the part of you that dreams isn't resting, it's working harder than it does all day. And what it's building in the dark might be the single reason your species is still alive. The real reason you dream has almost nothing to do with the story you remember when you wake up. And once you understand what's actually happening in there, you'll never look at a night of sleep the same way again. Let's start with the answer you were probably given. For most of the last century, two ideas owned this question. The first came from Sigmund Freud, around 1900, in a book called The Interpretation of Dreams. He argued that dreams were disguised wishes, your hidden wants, dressed up in symbols so your sleeping mind wouldn't be horrified by them. It was elegant, it was influential, and almost none of it survived contact with real data. The second idea arrived in 1977, from two Harvard psychiatrists named Alan Hobson and Robert McCarley. They proposed something called activation synthesis. Their claim was the opposite of Freud's, and in some ways harsher. They said dreams aren't messages at all, they're static. Your brainstem fires off random electrical noise while you sleep, and your cortex, desperate to make sense of anything, stitches that noise into a story the way you'd see faces in clouds. Under that theory, the dream means nothing. It's just the exhaust. And that's the version most people still carry around in their heads today. Dreams are random. Dreams are nonsense. Dreams are the brain idling. But here's the thing. If dreams were truly useless noise, evolution would have deleted them a long time ago. Because dreaming is not free. It is expensive, it is dangerous, and your body pays for it every single night. Think about what's actually happening to you when you dream. Roughly 90 minutes after you fall asleep, you slip into a phase called REM, rapid eye movement. And the moment you enter it, your body does something that should terrify you a little. It paralyzes itself, on purpose. A signal from your brainstem cuts the connection to almost every muscle you own, leaving you limp and locked in place. This is called rematonia, and it exists for one reason, so you don't act out whatever your brain is showing you. Because what your brain is showing you is not calm. Your heart rate climbs, your breathing goes irregular, your eyes dart back and forth behind closed lids, as if you're tracking something moving fast across a room. The regions of your brain that process emotion and visual imagery light up more than they do when you're wide awake. Meanwhile, the part responsible for logic and self-control, the prefrontal cortex, goes almost completely quiet. That's why dreams feel so real and so insane at the same time. The feeling center is screaming. The fact checker is asleep. So no, your brain is not idling. While you lie there unable to move, it is running one of the most intense states it will enter in a 24-hour cycle. The question is why it would spend a third of your life doing that, blind and paralyzed, if the payoff were nothing. And the answer, it turns out, is layered. Because dreaming doesn't do one thing. It does several, all at once, and each one is something your waking self quietly depends on. The first layer is memory. For years, scientists thought sleep just protected the things you'd learned that day, like putting a book down so the wind couldn't blow it away. But that undersells it. Researchers like Robert Stickgold at Harvard and Jan Born in Germany showed that sleep, and especially REM, doesn't just store memories. It edits them. It pulls the useful thread out of the day's noise, strips away the emotional static, and weaves the important parts into what you already know. Your brain isn't a hard drive while you dream. It's an editor. And the editor works at night because that's the only time you're not feeding it new footage. But memory is only the floor. The second layer is the one that might matter most of all, and it's the reason some therapists call dreaming overnight therapy. A researcher named Rosalind Cartwright spent decades studying people going through divorce, grief, and depression. She found something striking. The people who dreamed vividly about their pain, who actually processed the emotion inside the dream, were the ones who woke up healthier months later. The ones who didn't dream about it stayed stuck. Her reading was simple and profound. Dreaming takes the sting out of the memory while keeping the memory itself. It's the difference between remembering a wound and still feeling the knife. Matthew Walker at UC Berkeley put it even more bluntly. He described REM sleep as a kind of emotional first aid, a nightly process that strips the raw charge off the day's hardest moments so you can carry them without bleeding. And there's hard chemistry behind this. During REM, your brain switches off the main stress molecule, noradrenaline, almost entirely. It's the only time in a full day that your body processes painful memories in a completely stress-free chemical state. So the nightmare you had about the argument, the embarrassing moment, the loss, your brain was replaying it on purpose, in a safe room, with the volume on the fear turned all the way down, so that tomorrow you could think about it without falling apart. Dreaming didn't just record your life, it healed it. But there's a third layer, and this one is stranger, because it suggests your sleeping brain is rehearsing for things that haven't happened yet. In 2000, a philosopher named Antti Revonsuo proposed the threat simulation theory. His argument was that dreams are a flight simulator for danger. Your ancestors who dreamed about being chased, cornered, attacked, were running drills. Their brains were practicing the escape, the fight, the freeze, over and over, in perfect safety, so that when the real predator came in daylight, the body already knew the moves. It explains why dreams skew so heavily toward threat, toward falling, toward being hunted, toward showing up unprepared. Your brain isn't torturing you, it's training you. And then there's the fourth layer, the one that feels almost like magic: problem solving. There's a famous 2009 study, led by Denise Kay, at UC San Diego, published in the Proceedings of the National Academy of Sciences. They gave people a creative puzzle, let some of them nap into REM sleep, and tested them again after. The people who reached REM solved dramatically more of the puzzles than the people who only napped lightly or stayed awake. Not because they were more rested, because REM sleep had quietly connected ideas that their waking mind kept in separate boxes. This is the sleep-on-it effect made real. The dreaming brain takes two things that have nothing to do with each other and asks, what if they did? It's why artists wake up with a melody, why scientists wake up with a missing piece, why the answer that wouldn't come at your desk arrives at 6 a.m. while you're brushing your teeth. Your sleeping mind was building it the whole time. So now the picture is very different from the noise theory. Dreaming is memory editing, emotional surgery, danger rehearsal, and creative collision, all running at once in a body that has locked itself down so it won't get in the way. And that brings us to the part almost nobody talks about: the cost of losing it, because you can lose it. Certain medications, especially older antidepressants and some sleep aids, suppress REM almost completely. People on them often report, after years, a flatness they can't name. Not sadness exactly, more like the color has gone slightly out of things. And when those people stop the medication, their brains don't just go back to normal. They flood. It's called REM rebound. The brain, starved of dreaming, throws itself into long, intense, sometimes frightening dream nights, as if it's been saving up work it wasn't allowed to do. Your body was keeping a ledger the whole time, and it always comes back to collect. That rebound tells you something important. Dreaming is not optional decoration on top of sleep. It's load-bearing. Take it away, and something in you starts to quietly come apart, even if you can't point to where. Every human being who has ever lived has done this. Every person you've ever met spends their nights paralyzed and hallucinating on purpose, editing their past, diffusing their pain, rehearsing their fears, and connecting ideas they'll never remember connecting. And almost all of it is forgotten by breakfast, which is the final, strangest layer of all. The point of a dream was never for you to keep it. It was for you to be changed by it. The memory of the dream dissolves, but the work it did stays, woven into who you are when you open your eyes. You don't remember the editor. You only notice the film got better. So the next time you wake up with the faint ghost of a dream already slipping through your fingers, don't feel like you lost something. Feel like you got away with it. Your brain spent the night doing the one thing it could never do while you were watching. It rebuilt you. And then, gently, it let you forget, so you could wake up and just be the person it made.